Hi folks, you are already familiar with the LTSpice GUI and toolbox. In last couple of episodes, we have used the NMOS and pMOS together as CMOS for digital electronics applications. In today's episode, we will explore the transfer characteristics, that is ID versus VGS curves, using the same monolithic pMOSFET that we have used earlier. Then we will explore its drain characteristics, that is ID versus VDS curves. In both the cases, we will be using DC sweep in DC analysis. So stay tuned, stay focused. Hey guys, welcome back. Today we will be simulating the two different characteristics, that is transfer characteristics and drain characteristics of a pMOS. This pMOS we have used in last couple of episodes where we have created different circuits for various logic gates using CMOS. So we will be making the circuit and observing the characteristics of this pMOS. Hey guys, for last couple of episodes, we are using the GUI and not using the keyboard shortcuts. However, we have crossed multiple episodes and I think by now on, you are ready to use the keyboard shortcuts. For a designer, these keyboard shortcuts are very much time saving. And one thing I would like to emphasize here, which keyboard key is used for the shortcut. It's very simple. Generally, what you are doing, right? Usually the initial letter is there. There are little changes at some point, and here on the screen you can see that I have listed some of the frequently used keyboard shortcut. At left side we have the component or whatever action we are doing. I must write it as action, and right hand column I have keyboard shortcut. So first thing is that often we insert register, right? So the register will be inserted by the keyboard key once you hit R. And why it is showing smaller? Because you have hidden the key directly and you have not used any other keys. Similarly, for capacitor, we will hit the keyboard key C. Next comes the inductor. You can guess what will be. This is L. For voltage, that means once we want to insert any blank voltage source, later we can configure whether it is AC, DC or something else. For that, we will be using the keyboard key V. And you can see all of them are in small. That means you are hitting all these keys without touching any other key. Now comes the wiring. Wiring means when you are connecting wires, right? For that, you will be using the small w. That is, you are hitting the W key without touching any other key. For ground, we will be using G and it's small g. That means we are not touching any other key of the keyboard. Next is select and move component. That means whenever we are selecting any components and changing its position or changing the name of a component, we can use this key. To move something, that means select and move, we use M. And you can see it is small m. That means from the keyboard, we will hit the M key without touching any other key. Now, deleting any wiring or any component, or we want to remove any other thing like ground. Say, what keyboard key we will be using? We will be using the delete key. Why I have to write? Because delete has a ASCII code which is non-printable. So if I hit delete, right, nothing will come here. So these are the shortcuts. So these are the component or action and the keyboard shortcut. For resistor, we will be using small r. Capacitor, we will be using small c. Inductor, we will be using L. Voltage, we will be using B. Wiring, we will be using W. For ground, we will be using G. For select and move, that means move is the main thing, right? M. We'll be using M, and delete any wiring or component, we'll be using the delete. So this delete comes with a scissor symbol like this. Please remember that. Here all this keyboard shortcut. We will be using further episode, that means this episode and the upcoming episodes. So you can assume that you are going in a much more pro level of using the LTSpice. However, in narration, I will be saying that I am hitting the R or hitting the C from the keyboard, so you can understand. You have to follow this. So we are done here. Now let's move on to the circuitry. Here is LTSpice and let me double click it to open it. You can see that the interface has opened. So let me click the new schematic. So first I'll save the file, going to save as, and then I'll save it as pMOSFET characteristics. I'll click save the file. Now I'll go to the components and from there I'll pick the pMOS4. This is a monolithic pMOSFET model that we have used in last couple of episodes. So here I'll click place and I'll place it. Right click to vanish it. So the MOSFET is there. Let me zoom out a bit. And next I will place the voltages by clicking V from the keyboard. The first one is here and the second one is here. I'll right click to vanish it. Now I'll click on the R from the keyboard, get the resistances. I'll rotate it. I'll place it here and I'll place the second resistance here. This is a very simple circuit. I'll right click to vanish it. Now one thing for here, you can see the voltages are there. While interconnecting, I have to flip the plus and minus. For that, I'll hit the M key from the keyboard to select and move. Now I'll select Ctrl plus R to rotate it. So it has rotated clockwise 90 degrees. I'll again click Ctrl plus R to rotate it. So now you can see the voltage plus and minus terminals are flipped vertically. Now I'll click and place it. Again, I'll hit the M from the keyboard to select and move. I'll click and select. Here, I'll do the rotation again. From the keyboard, I hit Ctrl plus R twice. So first time, second time. You can see it has rotated. So I will click and place it. Now, again I'll click move. That is M from the keyboard and select it. I'll adjust a bit here. Right click to vanish it. Now I'll click save. Now I'll do the wiring. I'll hit W from the keyboard. I'll connect this resistance with the voltage source and the other terminal with the gate. Now from here I'll go up, connect the resistor. Now I'll connect this too. Next I'll click here, go downwards, click here, go right, click here, go up, click here. I will connect this with the ground line. I'll right click to vanish it. Go and save the file. One more thing, I have to place the ground. So I hit T from the keyboard and the ground comes. So I'll place it here. Right click to vanish it. I'll again hit W from the keyboard to get the wiring and I click here. I'll right click it, vanish it. I'll rename it. This is RG and this is RP. One more thing is remaining. This substrate connection is there. I'll hit W from the keyboard, bring up the wiring and I'll connect it with the ground line. I'll right click to vanish it. I'll rename this voltage source as VGS. I'll click OK and I'll type VDS. So this is VDS. Now I'll assign the value. I'll click it and DC value will be 0. Since we'll be doing this DC sweep, initially we'll keep it 0 and through sweep we'll change the voltage. And now again I'll assign the voltage. I'll assign voltage 0 here. I'll click OK. In both the cases we are assigning 0 and through the DC sweep we change both of the voltages. Now let me zoom out a bit so that we can fit the entire circuit here in the screen. Now I will go for one thing is that this resistance we have to assign a value here. It is 330 ohms and this is 33 ohms. Click OK in both cases. MOSFET length and width we have to give. We will use the same length and width that we have used in the CMOS gates for the digital simulation. So we will use the same value here, 20 micron, and here it is 200 micron. So I'll click OK here. The MOSFET is also done. I'll click save. Now I will click the SPICE directive. I'll give a .dc and place it here. Now I will right click. So for the transfer characteristics, that means IDS versus VGS curves, we will assign the first source as VGS, declare the sweep type as linear, start value will be 0, top value will be 5 and increment will be by 1. And the second source is VDS. Sweep type is linear, start value is 0 top value is 15 and increment is 1. So you can see we initially declared these two voltages as 0, and here we are doing the sweep, and there we are changing the voltages. For DC sweeping, you have to maintain this kind of conventions so that the simulation happen without a glitch. Now I'll click OK. I click to save it. Here let me go view and go to Spice netlist. It seems everything is okay here and I don't find any kind of things is missing. So let me close it. And now let me run the simulation. Let me go view and go to the Spice output log, and you can see that there are no errors. So simulation is fine. Now for this circuit, get the IDS versus VGS. To get the IDS versus VGS, we have to click here. Now here in the x-axis you can see it has from 0 to 5 volt, that the sweep we have done for VGS. That means in x-axis we have VGS, and y-axis we have the current that is going through RD, means this is the ID. So ID versus VGS. And here we are done with the transfer characteristic, and I'll close the graph here. And the circuit will remain same. However, I'll comment it. Here I'll right click and click in this particular button and make it a comment. That means we are not using this anymore. As soon as I make it comment, it becomes blue. So let me save it. And again, I'll go to the Spice directive. I will put a .dc command here. I'll click OK and I'll place it here. Now I have to configure this DC. Now for the drain characteristics, that is the IDS versus VDS, the first sweep will be VDS. It type is linear, start value 0, end value 15, increment is 1. The second source will be VGS, start value 0, top value is 5, increment is 1. So for IDS versus VDS, our first sweep is VDS and the second sweep will be on VGS, which is different from the previous case. So I'll click OK. I'll click fit to screen. So everything inside the screen is there, and I'll click save to save it. Now I'll run the simulation. Now I have to click this circuit and then I have to go view, Spice output log, and we don't have as such any errors here, and I close it. Now to get the IDS versus VDS, get the IDS, you have to get the current which is flowing through RD. I'll click here and you can see that here the VDS is swept from 0 to 15 volt, you can see, and here we have the drain characteristics, that is IDS versus VDS. We are getting the current ID which is going through this terminal to RD. So we are done here with the simulation and the output characteristics, that is the drain characteristics. So this way we can do both the transfer characteristics and drain characteristics using the single circuit. We are done here. Thank you very much for watching up to this point, and don't forget to like, share and subscribe. In case you have some dislikes, put that as in words in the comment section down below, and bye for today.